we need to calculate the distance from a point to a line, from a given point to a given line. And the first thing we need to establish up front is that when we talk about the distance from a point to a line, we always talk about the distance measured along a line or along a segment that's perpendicular to the given line. So we always measure the distance along that perpendicular segment. Talk about two ways to do it. Some texts focus just on a graphical representation. That is, you're in the coordinate plane and you sort of just do the whole thing by eye. That works well when your point happens to have integral values. For instance, if your point is at 6, 4, or 1, 2, or something like that. But if you're dealing with decimals and fractions, that kind of breaks down a little bit. So I'd like to show two ways to do it. Number one is the graphical representation. And number two is the algebraic representation. So let's talk about the graphical way of doing it first. Suppose I have this situation here, which is already presented. And let's further suppose I'm in the coordinate plane, such like this. Suppose this line goes through the point 1, 0, and also goes through the point 1, 7. So we can see it's a vertical line, and we can see that the line passes through all values of x that equal 1. And so we'd say the equation of this line is actually x equals 1. Let's suppose this point over here is 6, 2. This point is 6, 2. So the question is, how far is the point from the line? Well, you can see that the point is an infinite number of distances from different points on the line, but that's not what we mean when we say the distance from a point to a line. We mean, how far is this point from this line along this perpendicular segment? So that's the question for us. In order to answer the question, we need to identify this point right here. That point right there. So, if this is a vertical line, and this line is perpendicular to it, this is a horizontal line, which means our distance will be measured along this horizontal line. We can also see that the y value of this point is 2 units, which means this line is 2 units above the x-axis, which also means that any point on this segment has a vertical value of 2. Vertical value of 2. So we know that this point right here must have a vertical value of 2. All we need to do now is figure out the horizontal value. We also know that all the points on this vertical line have x value equal to 1. That's horizontal value equal to 1. So our point here is 1, 2. So the distance from this point to this line is the same as the distance from 6, 2 to 1, 2. We can actually find that distance using the distance formula. We know that d is equal to the square root of x2, in this case, we'll say 6, minus x1, which is 1, squared, plus y2, which is 2, minus y1, which is 2, squared. So d equals the square root of 5 squared, which is 25, plus 2 minus 2, which is 0, squared is still 0, so this goes away. Square root of 25, d equals 5 units. So the distance from this point to this line is 5 units. Always, again, always measured on that shortest perpendicular segment. Let's talk about the algebraic representation. That one's a little bit trickier. Let me erase this and we'll put up another set of facts. Okay, got a coordinate plane here, and we have a line. And I've identified the equation of that line as y equals negative x plus 2. Notice the negative slope coming down from left to right. Plus 2 is the y-intercept. And I have this point here, 6, 1. And I'd like to ask the question, how far is the point from the line? How far is the point from the line? To start with, let's identify the line along which we'll measure that distance. It's always the perpendicular segment. So we know it approximately lies in here someplace. That's where we're going to measure this distance from this point to this line. The next thing I'd like to do is find the equation of this line. I'd like to know the equation of the line that contains that segment, the line that goes like this. What would that equation be? Well, we know it's perpendicular to this given line. So the slope must be an opposite reciprocal. So that line will have the equation y equals, we've got negative 1 for a slope here, so the opposite of negative 1 is positive 1, and the reciprocal of positive 1 is positive 1. So the slope is positive, so we just write x. Positive x. positive 1x. And then we need to know the y-intercept. It's going to be down here in the negative somewhere. We'll find that in just a moment by doing the following. We're going to write this equation in what's called point-slope form. Point-slope form. So point-slope form is as follows. Y minus y1 is equal to m times x minus x1. This is point-slope form. So if I happen to know a point and the slope, I can plug them into this form right here to get the equation. So in this case, the question is, do we know any points? Yes, we know this given point 6,1. This line, perpendicular line, passes through that point 6,1. So I'll say that y minus 1 equals m. M is slope, and we already said the slope of this perpendicular line is 1, times x minus x1, which is 6. So there's my equation. It's in point-slope form still. I'd like to rearrange it and put it into slope-intercept form. So let's just do that. In order to do so, we can distribute the 1, which isn't going to change anything. Y minus 1 equals x minus 6. And then add 1 to each side. Y equals x minus 5. So this equation, y equals x minus 5, is the equation of the line that contains this perpendicular segment. We'll just write that over here. Now we have two equations. One for the original given line and one for the line containing this segment. But I'd like to know the coordinates of this point here. And we're trying to figure this out just with pure algebra, not with the graphical representation. So how can I find that point given these two linear equations? You may remember from algebra there's a process called solving systems of equations, and that's exactly how we find it. We simply solve this system of equations and we'll get the coordinates of this point right here. So we take y equals x minus 5 and y equals negative x plus 2. And we make a substitution. Instead of y, we take the x minus 5 and plug it in for this y down here. It becomes this. X minus 5 is equal to negative x plus 2. So now we can solve this for x. We add x to both sides. We have 2x minus 5 equals 2. Add 5 to both sides. We have 2x equals 7, and then divide by 2. X equals 3.5. That's my x value here. So this coordinate will be x, and that will, the coordinate will be 3.5 for x. And now we need to solve for y. How do we solve for y? We just take x and plug it into either one of these equations. We can just plug it into this one right here. To solve for x, we have y equals negative 3.5, that's my x value, plus 2. Negative 3.5 plus 2 is the same as 2 minus 3.5, which is negative 1.5. So that's my value here. Negative 1.5. So we haven't answered the question fully. We're trying to find the distance from this point to this line. But what we have done is we've identified this point, 3.5, negative 1.5, which is extremely important because now that we have these 2 points, we can use the distance formula to find the distance of this line. So we'll do that now. It's the difference in my x values, 6 minus 3.5 squared, plus 1 minus negative 1.5, and that's all squared. You've got to watch your minus signs in here. Therefore, my distance is equal to the square root of 6 minus 3.5 is 2.5. And 1 minus negative 1.5 is the same as 1 plus 1.5, which is actually 2.5 again. Like this. So now we need 2.5 squared. 2.5 squared is actually 6.25. And another 6.25. And so now we add these together. My distance is equal to the square root of 12.5. Let's reach for a calculator and get that number. And that number is approximately 3.54. So that's my distance. This point is 3.54, approximately 3.54 units from this line. So that's how we do it algebraically. If I could just walk through those steps one more time. First thing we do is try to identify the equation for the line that contains this segment. Okay? And the way that we do that is we look at the given slope, and then we determine the opposite reciprocal, which is the perpendicular slope. Okay? In this case, the given slope was -1, so the perpendicular slope was +1. Okay? Then we use the point slope form of a linear equation. We plug in the perpendicular slope, which in this case was 1, and then we plug in the coordinates of the given point, the point that we're trying to find the distance from the line from. 6, 1, so I've put in that for y and x, 6, 1. Rewrite it in the linear equation form. Y equals x minus 5. And with that we build a system of equations to determine the coordinates of this point right here. We've done that here. The coordinates of the point, we found the x first was 3.5. We use that 3.5 then to solve for y, -1.5. And now we've got two endpoints on a segment. We can use the distance formula to find the distance of that segment. That is finding the distance from a point to a line. We'll look at one more example and run through it quickly. Here's the next problem. It says find the distance from the point 3,8 to the line y equals -1/2 x plus 4. And I'll do this without a graph, just pure algebra. Let's take a look. We know that the distance between this point and this line lies along a segment that is contained by a line perpendicular to this one. So the first thing we can figure out is the slope. What would be the slope of that line? Well, we can see that the slope of this line is -1/2. So the slope of the line we're looking for will be equal to +2, the opposite reciprocal of -1/2. M equals 2. Now we use point slope form of a linear equation. Y minus y1 is equal to slope times x minus x1. There's our equation right there. This is the equation of the line that contains this point, but is perpendicular to this line here. And it's not in a form we're familiar with, so let's just change it around a little bit, see if we can get it into slope-intercept form. So to do that, we distribute the 2. Y minus 8 equals 2x minus 6, 2 times -3. And then we'll add 8 to both sides. Y equals 2x plus 2. There's my equation. Okay, so we have an equation here. This is the new equation we just found. This is the equation of the line that contains the segment that's perpendicular to this line here, but goes to this point. And this is my original equation. So we'll use these two equations, solve a system of equations, and that will tell us the point at which those two lines intersect. So to do that, I'll take this expression on the left side, -1/2 x plus 4, and set it equal to this expression on the right side, 2x plus 2. Again, I have a y and a y, so by substitution or by the transitive property, this expression must be equal to this expression where those two lines cross. So we need to solve this. I'll add 1/2 x to each side. And so we end up with 4 equals 2.5x plus 2. Now we'll subtract 2 from each side. And we end up here with 2.5x. I just brought that to the other side. I'll bring this to the other side as well. Those cancel. 4 minus 2 is 2. Finally, we need to divide by 2.5. And we find that x is equal to 2 divided by 2.5. 2 divided by 2.5. That's 0.8. Okay. So that's our x value for the point at which this line crosses this line. That's my x value. Now the next thing we need to do is go ahead and find the y value. So we'll just use either one of these equations. We'll grab this equation right here because it looks a little easier. That's fine. So to find this, we plug the x in. 2 times 0.8 plus 2. 2 times 0.8 is 1.6. And 1.6 plus 2 is 3.6. So that's my x and y value, 0.8 and 3.6. Those are the coordinates of the point where my segment, which is the distance from this point to that line, where my segment intersects this original given line. I'm going to just show you a quick diagram of it in a moment, just in case anything's still kicking around and you can't quite figure out where to put it in. But these are the coordinates of that point. So now, to finish the problem, all I need to do is find the distance from this point, 3.8, to this point, 0.8, 3.6. Let's do the distance formula over here. We take the difference of our x values, 0.8 minus 3, and we square that. And we add to that the difference of our y values, 3.6 minus 8. And we need to square that as well. Okay, there's our distance formula. So the math's going to get a little bit ugly here. We definitely need a calculator for this one. 0.8 minus 3 is negative 2.2 squared. And 3.6 minus 8 is negative 4.4 squared. Okay, I'm going to grab a calculator. We'll put this whole thing right in the calculator. Let's see what we get for it. Okay, as we work through it, we find that d is equal to the square root of 4.84, that's negative 2.2 squared, plus 19.36. 19.36 is negative 4.4 squared. When we add those up, we get 24.2. The square root of 24.2 rounds to approximately 4.92. So that's our final answer. That is the distance from this given point to this given line. I said I'd take a quick look at the geometric representation just in case you're struggling to keep all these pieces in place. And I'm just going to sketch that so we can get an idea. Okay, in the coordinate plane, this line lies somewhere around here. 4 is the y-intercept, and negative 1 over 2 is my slope. So go down 1 over 2. Looks something like this. And the point we're interested in is 3.8. 3.8, probably be around there somewhere, approximately. And so we found that distance along this segment, which is perpendicular. That's where we found it. So the process again was, we identified the slope of this line, then we plugged the point and the slope into the point-slope form of a linear equation. Then we changed that into a linear equation in the form of y equals mx plus b, slope-intercept form. Then we used the two equations to solve for this point right here. That's my new endpoint. I need these two endpoints to find that distance. Once we solved for that endpoint, we took the point 3.8 and the new endpoint we found, and we plugged them into the distance formula, and that's our distance from a point to a line.